Okay, so question 11, the last question in this November 2013 paper 1 examination. This is a linear programming problem, and the question says the following. A company manufactures both short sleeve shirts and long sleeve shirts. I'll just label them S and L. And below they give us some constraints, some information about the production process. So they tell us that no more than 80 short sleeve shirts are to be produced. A minimum of 50 long sleeve shirts are to be produced. At most 5 long sleeve shirts per short sleeve shirt are to be produced. Each short sleeve shirt has 5 buttons and each long sleeve shirt has 4 buttons, and we have a total of 800 buttons available for the production. Question 11.1. Write down the constraints. Okay. So from number 1 we can see that no more than 80 short sleeve shirts has to be produced. So that gives us a maximum of 80. They also told us to let short sleeve shirts be X and the long sleeve shirts be Y. Okay, so no more than 80 short sleeve shirts, no more than 80 X, or no more than 80 of X, so X has to be less than or equal to 80. Okay, from number 2 we can see that the long sleeve shirts have to be at least 50, a minimum of 50. So Y, which are your long sleeve shirts, have to be at least 50, so it has to be greater or equal to 50. From number 3, they say that at most 5 long sleeve shirts for every short sleeve shirt is produced. Okay, so that tells us that if you take the number of short sleeve shirts and multiply it by 5, that must be the maximum number of long sleeve shirts available. Okay, so that means that Y must be less than or equal to 5 times the number of short sleeve shirts. Okay, from number 4 and number 5 together, we see this from 4 and 5. Okay, we have a total of 800 buttons available for production. Each long sleeve shirt gets 4 buttons and each short one gets 5 buttons. So we know that each short sleeve shirt, so each X has 5 buttons, so 5 times X, that's the number of buttons in total for short sleeve shirts, plus the number of buttons for long sleeve shirts, must total less than or equal to 800. So those are your constraints that you need to write down. Okay, and it's always nice to say that, just to add this one in to make sure you get your marks, that X and Y both have to be greater or equal to 0. And they won't penalize you for this usually. The next question, 11.2, sketch the system of constraints that we just calculated. Okay, so we've calculated these 4. Now we need to sketch them on the graph. Okay, I just have a rough graph here. I don't have the graph paper, so this won't be as accurate as it might have been. You will be provided with graph paper in the exam. Okay, so let's first look at X being less than or equal to 80. Okay, we can just replace that inequality with an equal sign. So X being equal to 80, what would that look like? That's just a straight line, vertical line straight up. Okay, we'll call this line number 1 just for reference. And number 2 we said was Y has to be greater or equal to 50. So we look on the Y axis here for 50, and we'll draw a horizontal line. We'll call this number 2. Okay, the third constraint we had was Y has to be less than or equal to 5x. Okay, so Y less than or equal to 5x. Again, if we replace that with an equal sign, we get Y equals 5x. And how are we going to draw that? Well, remember that Y equals some constant times x is just a straight line, and the value in front, the coefficient, just determines how steep that goes. So we can have one point here at the origin, because the Y-intercept will be 0 there. And then we just choose one x value, doesn't matter which one. Let's say x equals 20, And so what would y be? Y equals 5 times x, so y equals 5 times 20 would give you 100. So another point would be here, at 20 and 100. And all you do is you just connect those lines. And we'll call this number 3. Now the fourth and final equation we have, inequality we have here to draw, is 5x plus 4y less than or equal to 800. 5x plus 4y less than or equal to 800. Now the easiest way to draw one of these, just find your x-intercept and your y-intercept and connect those points. So to find an x-intercept, we'll make a y value 0, so that'll just fall away. 4 times 0 is 0. And now we solve for x. 5x equals 800. So if we say that, let's do some rough work here. 5x equals 800. Divide both sides by 5. We get x equals 800 over 5, which is 160. Okay, so our x value here would be 160. And to find a y-intercept, we just make x 0, so we'll have 4y equals 800. And divide both sides by 4, we get y equals to 200. So 200 would be our y-intercept. And all we do is you connect those lines up. See if I can try and draw a straight line here. Fairly straight. And we'll call this one number 4. Okay, now we need to find the feasible region. So which one of these regions is the feasible region? Well, let's have a look. Number 1, so that's this one here. We know that x has to be less than 80. So we're looking for values on the less than side. Okay, number 2, y has to be greater than 50. Here's number 2, greater than, we're looking for values above that value, that line. Okay, the third one, y is less than 5x. This number 3 here. We're looking for where y is less than, so below the line. And our last one, again, y is the important part, so where y is less than some value. So we're looking below number 4's line. So that'll be over there. And where do all these arrows point to? We're looking above this line, below that line, and to the left of this line. So here's our feasible region. And remember to label your axes. So this one, we'd have to label X, and we'd have to call it short sleeved shirts. And the same here, call this Y, and we label it long sleeved shirts. And that's it, 11.2 is done. Let's see what else they ask. 11.3, so a profit of 30 Rand is made on each short sleeve shirt and a profit of 20 Rand on each long sleeve shirt. Now write down the profit function. This is a pretty straightforward 1 mark question. We'll say the total profit is equal to the profit on a short sleeve shirt plus the profit on a long sleeve shirt, right? So the profit on a short sleeve shirt is 30 Rand, so it's 30 times the number of short sleeved shirts you sell, plus the profit on a long sleeved shirt is 20 Rand, so it's plus 20 times the number of long sleeved shirts you sell. Easy as that for 1 mark. Next question, 11.3.2. Determine the number of short sleeved shirts and long sleeved shirts that must be manufactured to provide the maximum profit. Because there's a profit function, now we need to maximize that. Okay, to do that, there are a couple of ways we can look at that. The first way is to take every vertex from the feasible region. So that'll be this point here, that point, this one, and that one. Substitute those coordinates in and see which one gives you the biggest answer. That's an easy way, can't really make mistakes, but it might take a bit long. Another way to do it is to look at your profit function and rewrite it to find the gradient of that function. Let's see what happens then. So we'll take the profit function, P equals 30x plus 20y, and we'll rewrite it in terms of y to find the gradient. So we'll say this implies that p minus 30x equals 20y, and then we'll divide both sides by 20. So we'll have p over 20 minus 30 over 20 x equals y. So now what is your gradient in a straight line? We know a straight line has this equation, y equals mx plus c, and this here is your gradient. So in this case your gradient will be negative 30 over 20, or simplified to negative 3 over 2. Now once you have this gradient, we can put this gradient on here somewhere. So we need negative 3 over 2, so that is y change over x change. So we can say if we move 2 on the y-axis and 3 on the 2 on the x-axis and change y and 3 on the y-axis. Let's make that 30. So for every 2 we move across, we move 1 up. Well, the easiest way actually to do this one is, again, you just connect 20 and the 30 there. So now we have the gradient of that function, but it doesn't need to be there. It can move anywhere. So now you can take a ruler or something, some straight edge that you have, and just keep on sliding this function at the same gradient, and then the last point you reach, which in this case looks like it'll either be that one or that one, will be your maximum profit. And then once you've found it, you just substitute the point in to find your actual profit. Okay, so because I'm not sure, we'll do both of these points to find out. But we need the coordinates first. So let's find the coordinates of this point here. Let's call this point A. Okay, we know the x value here is 80. But what is the y value? Okay, to find the y value, you can probably just read it off your graph if you've been drawing it accurately. It looks like it'll be 100 if we read it off the graph. But let's just calculate it to make sure. We know x equals 80, and the other line that it crosses is this one here, number 4, which is 5x plus 4y equals 800. So let's substitute x equals 80 in here. 5 times 80 give us what? That'll give us 400. Okay, so 4y equals 800 minus that 400. 4y equals 400. Divide both sides by 100. Divide by both sides by 4, I mean. And that'll give us y equals 100. Maybe let me just do that calculation quickly. So we'll have 5 times 80 plus 4y equals 800. So 4y is equal to 800 minus 400. That'll give us 4y equals 400, and therefore divide both sides by 4, y equals 100. So we're going to see the y value there is 100. Let's call this point B. And now we need to find the x and the y value here. Okay, to do that we need to do a simultaneous equation for number 3 and number 4. Okay, so let's do that over here. Number 3 is y equals 5x, and number 4 is 5x plus 4y equals 800. But instead of y, we can just plug 5x. So we have 5x plus 4 times 5x equals 800. Okay, so that's 20x plus 5x, 25x equals 800. And if we solve for x here, we get x equals 800 divided by 25, and what will that give us? That will give us 800 divided by 25 will give us, I'm not really sure. 800 over 25, let me get the calculator quickly. just to work this out, 800 divided by 25, that's equal to 32. Okay, so our x value here, 32, and what is a y value? We just plug this value back into our equation. So y equals 5 times 32, and that is equal to 160. Okay, so let me rearrange this quickly. So 32 and 160. There we go. So we know it'll either be at B or A where the maximum profit will happen. So now our maximum profit function is this. So let's say we've got A, we calculate it to be 80 and 100. B, we calculate it to be 32 and 160. Now let's see which one gives us maximum profit. So P equals 30 times X. X was 80 plus 20 times Y, and Y was 100. So that will be equal to 30 times 80 is 2,400 plus 20 times 100 is 2,000, and that is equal to 4,400. Okay, if we do number B, profit equals 30 times X plus 20 times Y, and that is equal to 30 times 32, that gives us 960, plus 160 times 220 gives us 3,200. And this is then equal to 4,160. Okay, so obviously we see that point A here, that'll give us our maximum profit. X is 80, Y is 100. They ask us for the number of short sleeve shirts and number of long sleeve shirts that will give us maximum profit, which in this case would be our point A. So number of short sleeve shirts 80, number of long sleeve shirts 100. That'll give us our maximum profit. Okay. Now, question 11.4. If the objective profit function is given by profit equals AX plus BY, determine A over B if P, the profit, is maximized at each value of Y between 100 and 160. Now this might be a bit tricky, so I suggest we have a look at the graph again. So we want to maximize P between Y equals 100 and Y equals 160. Okay, so between 100, so it's between 100 here and 160. So in this range we want to maximize the profit. And the maximum profit will be on this line everywhere. Okay, because that's the only line in this section that touches the feasible, these two lines touch the feasible region. But we can see this line has a much higher values if you substitute in, so it will be either on this line or that line, but it's pretty obvious that it will be on this number 4 line here. If it's not obvious to you, then you can try both. You can do both, equal both parts, and see which one gives you the right answer. But because we know it's on this line, we need to find what the gradient of this line is. Okay? Because why do we need that? Well, let's see. If we have this equation P equals AX plus BY, and we want to maximize the profit, just like we did in the previous question, we need to find the gradient if we have Y equals. So let's rearrange this equation. We'll say P minus AX equals BY. Divide both sides by B. We get P over B minus A over B equals to X. Okay, so now the gradient we have here is negative A over B. So M equals negative A over B. That's where the profit will be maximized. And now we saw that between Y equals 100 and Y equals 160, profit will be maximized along this line. So what's the gradient of this line? Well, this is number 4 here. it's the 5x plus 4y equals 800. So the 5x plus 4y equals 800. Let's find the gradient of this equation. Well, let's say 4y is equal to 800 minus 5x. Divide both sides by 4, we've got y equals 200 minus 5 over 4x. Okay, so this gradient is negative 5 over 4. So that's where it will be maximized, and according to the profit function, that's where that will be maximized. So we need to equate these two gradients. So we're going to say that negative 5 over 4 is equal to negative a over b. And therefore 5 over 4 would be equal to a over b. That's it. So in this question, it takes a bit of insight to realize what they mean by this. In this case, that's the gradient of the profit function, so that's where the profit function is maximized. And then we just look on our graph in the region they specified, this region here, to see which of the lines are in contact with the feasible region. And then we check what the gradient is of that line. Like I said, you could also have thought it might have been this line, but to test that, we could see over here, if we take that point at 100, so 100 and whatever the x value is, so x and 100, if you calculated this point and you substituted that into your original profit function, you would see that that does not maximize the value at y equals 100, because at a here, that's where the value is maximized. So we can see it's along this line instead of along this line that the profit is maximized. And that's why we use the gradient of line number 4 here. Okay, so that is it for paper 1, November 2013. Thanks for watching.